told by the common camel. Matthew Lee Knowles, October 2013. Questions extracted from Charles Darwin's on the origin of species, by means of natural selection, left bracket 6th edition right bracket. Passing over allusions to the subject, in the classical writers Aristotle, in his Physicauscultations, Lib.2, Cap.8, S.2, after remarking that rain does not fall in order to make the corn grow, any more than it falls to spoil the farmer's corn, when threshed out of doors, applies the same argument to organization. And that's as translated by Mr. Clare Breese, who first pointed out the passage to me. So what hinders the different parts of the body from having this merely accidental relation in nature? Who can explain why one species ranges widely and is very numerous, and why another allied species has a narrow range and is rare? I do not dispute that these capacities have added largely to the value of most of our domesticated productions. But how could a savage possibly know, when he first tamed an animal, whether it would vary in succeeding generations, and whether it would endure other climates? Has the little variability of the ass and goose, or the small power of endurance of warmth by the reindeer, or of cold by the common camel, prevented their domestication? When we bear in mind that Britain has now not one peculiar mammal, and France but few distinct from those of Germany, and so with Hungary, Spain etc., but that each of these kingdoms possesses several peculiar breeds of cattle, sheep, etc., we must admit that many domestic breeds must have originated in Europe. For whence otherwise could they have been derived? Even in the case of the breeds of the domestic dog, throughout the world, which I admit are descended from several wild species, it cannot be doubted that there has been an immense amount of inherited variation. For who will believe that animals, closely resembling the Italian Greyhound, the Bloodhound, the Bulldog, Pug Dog, or Blenheim Spaniel, etc. So in like all wild canidaever, existed in a state of nature? If the several breeds are not varieties, and have not proceeded from the rock pigeon, they must have descended from at least 7 or 8 aboriginal stocks. For it is impossible to make the present domestic breeds by the crossing of any lesser number. How, for instance, could a pouter be produced by crossing 2 breeds, unless one of the parent stocks possessed the characteristic enormous crop? May not those naturalists who, knowing far less of the laws of inheritance than does the breeder, and knowing no more than he does of the intermediate links in the long lines of descent, yet admit that many of our domestic races are descended from the same parents, may they not learn a lesson of caution when they derive the idea of species in a state of nature, being lineal descendants of other species? Some authors use the term variation, in a technical sense, as implying a modification, directly due to the physical conditions of life. And variations, in this sense are supposed not to be inherited. But who can say that the dwarfed condition of shells, in the brackish waters of the Baltic, or dwarfed plants on alpine summits, or the thicker fur of an animal, from far northwards, would not in some cases, be inherited for at least a few generations? A wide distance between the homes of 2 doubtful forms leads many naturalists to rank them as distinct species. But what distance, it has been well asked, will suffice if that between America and Europe is ample? Will that between Europe and the Azores, or Madeira, or the Canaries, or between the several islets of these small archipelagos, be sufficient? How have all those exquisite adaptations of one part of the organization to another part, and to the conditions of life, and of one organic being to another being, been perfected? Again it may be asked, how is it that varieties, which I have called incipient species, become ultimately converted into good and distinct species, which in most cases obviously differ from each other far more than do the varieties of the same species? How do those groups of species, which constitute what are called distinct genera, and which differ from each other more than do the species of the same genus, arise? Why does it not double or quadruple its numbers? How will the struggle for existence, briefly discussed in the last chapter, act in regard to variation? Can the principle of selection, which we have seen is so potent in the hands of man, apply under nature? Can it then be thought improbable, seeing that variations useful to man have undoubtedly occurred, that other variations useful in some way to each being in the great and complex battle of life should occur in the course of many successive generations? If such do occur, can we doubt, remembering that many more individuals are born than can possibly survive, that individuals having any advantage, however slight, over others, would have the best chance of surviving and procreating their kind? In the literal sense of the word, no doubt, natural selection is a false term. But whoever objected to chemists speaking of the elective affinities of the various elements? It has been said that I speak of natural selection as an active power or deity. But who objects to an author speaking of the attraction of gravity as ruling the movements of the planets? As man can produce, and certainly has produced, a great result by his methodical and unconscious means of selection, what may not natural selection effect? Can we wonder then, that nature's productions should be far truer in character than man's productions? That they should be infinitely better adapted to the most complex conditions of life, and should plainly bear the stamp of far higher workmanship? What reason, it may be asked, is there for supposing in these cases, that two individuals ever concur in reproduction? How then, comes it that such a vast number of the seedlings are mongrelized? The tendency to reversion may often check or prevent the work. But as this tendency has not prevented man from forming by selection numerous domestic races, why should it prevail against natural selection? How then, does the lesser difference between varieties become augmented into the greater difference between species? But how, it may be asked, can any analogous principle apply in nature? But it may be objected that if all organic beings thus tend to rise in the scale, how is it that throughout the world a multitude of the lowest forms still exist? And how is it that in each great class some forms are far more highly developed than others? Why have not the more highly developed forms everywhere supplanted and exterminated the lower? Look into the first dawn of life, when all organic beings, as we may believe, presented the simplest structure. How, it has been asked, could the first step in the advancement or differentiation of parts have arisen? What then checks an indefinite increase in the number of species? Thus it is well known to furriers that animals of the same species have thicker and better fur the further north they live. But who can tell how much of this difference may be due to the warmest clad individuals having been favored and preserved during many generations, and how much to the action of the severe climate? What can be more singular than the relation in cats between complete whiteness and blue eyes with deafness, or between the tortoise-shell killer and the female sex? Or in pigeons, between their feathered feet and skin betwixt the outer toes, or between the presence of more or less down on the young pigeon when first hatched, with the future killer of its plumage? Or again, the relation between the hair and the teeth in the naked Turkish dog, though here no doubt homology comes into play. Why should this be so? On the ordinary view of each species, having been independently created, why should that part of the structure, which differs from the same part, in other independently created species of the same genus, be more variable than those parts, which are closely alike in the several species? What now are we to say to these several facts? These difficulties and objections may be classed under the following heads. First, why, if species have descended from other species by fine gradations, do we not everywhere see innumerable transitional forms? Why is not all nature in confusion, instead of the species being, as we see them, well defined? Secondly, is it possible that an animal having, for instance, the structure and habits of a bat, could have been formed by the modification of some other animal with widely different habits and structure? Can we believe that natural selection could produce, on the one hand, an organ of trifling importance, such as the tail of a giraffe, which serves as a fly flapper, and on the other hand, an organ so wonderful as the eye? Thirdly, can instincts be acquired and modified through natural selection? What shall we say to the instinct which leads the bee to make cells, and which has practically anticipated the discoveries of profound mathematicians? Fourthly, how can we account for species when crossed being sterile and producing sterile offspring, whereas when varieties are crossed, their fertility is unimpaired? But as by this theory innumerable transitional forms must have existed, why do we not find them embedded in countless numbers in the crust of the earth? But in the intermediate region, having intermediate conditions of life, why do we not now find closely linking intermediate varieties? It has been asked by the opponents of such views, as I hold, how for instance, could a land carnivorous animal have been converted into one with aquatic habits? For how could the animal, in its transitional state, have subsisted? If about a dozen genera of birds were to become extinct, who would have ventured to surmise that birds might have existed which used their wings solely as flappers, like the logger-headed duck Micropterus of Aton? As fins in the water, and as front legs on the land, like the penguin. As sails, like the ostrich. And functionally for no purpose, like the apteryx. If this had been effected, who would have ever imagined that in an early transitional state, they had been inhabitants of the open ocean, and had used their incipient organs of flight exclusively, so far as we know, to escape being devoured by other fish? Can a more striking instance of adaptation be given than that of a woodpecker for climbing trees and seizing insects in the chinks of the bark? What can be plainer than that the webbed feet of ducks and geese are formed for swimming? But may not this inference be presumptuous? Have we any right to assume that the Creator works by intellectual powers like those of man? Let this process go on for millions of years. And during each year, on millions of individuals of many kinds. And may we not believe that a living optical instrument might thus be formed as superior to one of glass as the works of the Creator or to those of man? If all pedunculated cirripedes had become extinct, and they have suffered far more extinction than have sessile cirripedes, who would ever have imagined that the branchiae in this latter family had originally existed as organs for preventing the ova from being washed out of the sac? Why on the theory of creation should there be so much variety and so little real novelty? Why should all the parts and organs of many independent beings, each supposed to have been separately created for its own proper place in nature, be so commonly linked together by graduated steps? Why should not nature take a sudden leap from structure to structure? Were the beautiful volute and cone shells of the Eocene epoch, and the gracefully sculptured ammonites of the secondary period, created that man might ages afterwards admire them in his cabinet? Few objects are more beautiful than the minute silicious cases of the Diatomasa. Were these created that they might be examined and admired under the higher powers of the microscope? Can we consider the sting of the bee as perfect, which when used against many kinds of enemies, cannot be withdrawn, owing to the backward serratures, and thus inevitably causes the death of the insect, by tearing out its viscera? If we admire the truly wonderful power of scent, by which the males of many insects find their females, can we admire the production, for this single purpose, of thousands of drones, which are utterly useless to the community for any other purpose, and which are ultimately slaughtered by their industrious and sterile sisters? If we admire the several ingenious contrivances by which orchids and many other plants are fertilized through insect agency, can we consider as equally perfect the elaboration of dense clouds of pollen by our fir trees, so that a few granules may be wafted by chance onto the ovules? Cannot our critics conceive that a biennial plant, or one of the lower animals, might range into a cold climate, and perish there every winter? And yet, owing to advantages gained through natural selection, survive from year to year by means of its seeds or ova. The celebrated paleontologist Braun, at the close of his German translation of this work, asks how on the principle of natural selection can a variety live side by side with the parent species. Braun also insists that distinct species never differ from each other in single characters, but in many parts. And he asks how it always comes that many parts of the organization should have been modified at the same time through variation and natural selection. But with respect to Nagelli's doctrine of an innate tendency towards perfection or progressive development, can it be said in the case of these strongly pronounced variations that the plants have been caught in the act of progressing towards a higher state of development? Mr. Mivart then asks, and this is his second objection, if natural selection be so potent, and if high browsing be so great an advantage, why has not any other hoofed, quadruped acquired a long neck and lofty stature, besides the giraffe, and in a lesser degree, the camel, guanaco and macropenia? Or again, why has not any member of the group acquired a long proboscis? In every meadow in England, in which trees grow, we see the lower branches trimmed or planed to an exact level by the browsing of the horses or cattle. And what advantage would it be, for instance, to sheep, if kept there, to acquire slightly longer necks? One writer asks, why has not the ostrich acquired the power of flight? Therefore Sir C. Lyell asks, and assigns certain reasons in answer, why have not seals and bats given birth on such islands to forms fitted to live on the land? Lastly, more than one writer has asked, why have some animals had their mental powers more highly developed than others, as such development would be advantageous to all? Why have not apes acquired the intellectual powers of man? But how to obtain the beginning of such useful development? In answer, it may be asked, why should not the early progenitors of the whales with baleen have possessed a mouth constructed something like the lamellated beak of a duck? Mr. Mivart asks, is it conceivable that the young of any animal was ever saved from destruction by accidentally sucking a drop of scarcely nutritious fluid from an accidentally hypertrophied cutaneous gland of its mother? And even if one was so, what chance was there of the perpetuation of such a variation? Now with the early progenitors of mammals, almost before they deserved to be thus designated, is it not at least possible that the young might have been similarly nourished? Mr. Mivart then asks, how did natural selection remove in the adult kangaroo and in most other mammals, on the assumption that they are descended from a marsupial form, this at least perfectly innocent and harmless structure? With respect to these organs, Mr. Mivart, as on so many previous occasions, asks, what would be the utility of the first, rudimentary beginnings of such structures, and how could such incipient buddings have ever preserved the life of a single echinus? It has often been asked, if natural selection be so potent, why has not this or that structure been gained by certain species, to which it would apparently have been advantageous? Why, it has been asked, if instinct be variable, has it not granted to the bee the ability to use some other material when wax was deficient? But what other natural material could bees use? Mr. Hudson is a strong disbeliever in evolution, but he appears to have been so much struck by the imperfect instincts of the Molothrus bonriensis that he quotes my words, and asks, must we consider these habits not as especially endowed or created instincts, but as small consequences of one general law, namely transition? what can be more extraordinary than these well-ascertained facts? As natural selection acts only by the accumulation of slight modifications of structure or instinct, each profitable to the individual under its conditions of life, it may reasonably be asked how a long and graduated succession of modified architectural instincts, all tending towards the present perfect plan of construction, could have profited the progenitors of the hive bee. Now what special difficulty would there be in natural selection, preserving all the slight individual variations in the shape of the beak, which were better and better adapted to break open the seeds, until a beak was formed, as well constructed for this purpose, as that of the nuthatch, at the same time that habit, or compulsion, or spontaneous variations of taste, led the bird to become more and more of a seed-eater. Is it then very improbable that the natural selection of individual swifts, which secreted more and more saliva, should at last produce a species with instincts leading it to neglect other materials, and to make its nest exclusively of inspissated saliva? It may well be asked how it is possible to reconcile this case with the theory of natural selection. Now do these complex and singular rules indicate that species have been endowed with sterility simply to prevent their becoming confounded in nature? For why should the sterility be so extremely different in degree when various species are crossed, all of which we must suppose it would be equally important to keep from blending together? Why should the degree of sterility be innately variable in the individuals of the same species? Why should some species cross with facility and yet produce very sterile hybrids, and other species cross with extreme difficulty and yet produce fairly fertile hybrids? Why should there often be so great a difference in the result of a reciprocal cross between the same two species? Why, it may even be asked, has the production of hybrids been permitted? Take the case of any two species which, when crossed, produced few and sterile offspring. Now, what is there which could favor the survival of those individuals which happen to be endowed in a slightly higher degree with mutual infertility, and which thus approached by one small step towards absolute sterility? Why then is not every geological formation and every stratum full of such intermediate links? Admitting then that gneiss, mica schist, granite diorite, etc. were once necessarily covered up, how can we account for the naked and extensive areas of such rocks in many parts of the world, except on the belief that they have subsequently been completely denuded of all overlying strata? But look at the penguins of the Southern Ocean. Have not these birds their front limbs in this precise intermediate state of neither true arms nor true wings? I do not suppose that we here see the real transitional grades through which the wings of birds have passed. But what special difficulty is there in believing that it might profit the modified descendants of the penguin first to become enabled to flap along the surface of the sea like the logger-headed duck, and ultimately to rise from its surface and glide through the air? Had it not been for the rare accident of the preservation of footsteps in the new red sandstone of the United States, who would have ventured to suppose that no less than at least 30 different bird-like animals, some of gigantic size, existed during that period? But may not the areas of preponderant movement have changed in the lapse of ages? Is this the case? It is not an insuperable difficulty that foraminifera have not, as insisted on by Dr. Carpenter, progressed in organization since even the Laurentian epoch. For some organisms would have to remain fitted for simple conditions of life, and what could be better fitted for this end than these lowly organized protozoa? To attempt to compare members of distinct types in the scale of highness seems hopeless. Who will decide whether a cuttlefish be higher than a bee, that insect which the great Von Baer believed to be in fact more highly organized than a fish, although upon another type? Now, what does this remarkable law of the succession of the same types within the same areas mean? for he may ask in vain, where are the numberless transitional links, which must formerly have connected the closely allied, or representative species, found in the successive stages of the same great formation? He may ask, where are the remains of those infinitely numerous organisms, which must have existed long before the Cambrian system was deposited? But if the same species can be produced at two separate points, why do we not find a single mammal common to Europe and Australia or South America? The conditions of life are nearly the same, so that a multitude of European animals and plants have become naturalized in America and Australia. And some of the aboriginal plants are identically the same at these distant points of the northern and southern hemispheres. With such facts before us, can we doubt that the many birds, which are annually blown by gales across great spaces of ocean, and which annually migrate, for instance, the millions of quails across the Mediterranean, must occasionally transport a few seeds, embedded in dirt adhering to their feet or beaks? Why, it may be asked, has the supposed creative force produced bats and no other mammals on remote islands? Would the just hatched young sometimes adhere to the feet of birds roosting on the ground, and thus get transported? Why should this be so? Why should the species, which are supposed to have been created in the Galapagos archipelago and nowhere else, bear so plainly the stamp of affinity to those created in America? But how is it that many of the immigrants have been differently modified, though only in a small degree, in islands situated within sight of each other, having the same geological nature, the same height, climate, etc.? Now let us suppose the mocking thrush of Chatham Island to be blown to Charles Island, which has its own mocking thrush. Why should it succeed in establishing itself there? But what is meant by this system? As descent has universally been used in classing together the individuals of the same species, though the males and females and lordly are sometimes extremely different. And as it has been used in classing varieties which have undergone a certain, and sometimes a considerable amount of modification, may not this same element of descent have been unconsciously used in grouping species under genera, and genera under higher groups, all under the so-called natural system? But why, it may be asked, are certain forms treated as the mimicked, and others as the mimickers? We are next led to inquire what reason can be assigned for certain butterflies and moths so often assuming the dress of another and quite distinct form. Why, to the perplexity of naturalists, has nature condescended to the tricks of the stage? What can be more curious than that the hand of a man, formed for grasping, that of a mole for digging, the leg of the horse, the paddle of the porpoise, and the wing of the bat, should all be constructed on the same pattern, and should include similar bones, in the same relative positions? Professor Flower, from whom these statements are taken, remarks in conclusion: we may call this conformity to type, without getting much nearer to an explanation of the phenomenon. And he then adds, but is it not powerfully suggestive of true relationship, of inheritance from a common ancestor? We see the same great law in the construction of the mouths of insects. What can be more different than the immensely long spiral proboscis of a sphinx moth, the curious folded one of a bee or bug, and the great jaws of a beetle? Why should the brain be enclosed in a box composed of such numerous and such extraordinarily shaped pieces of bone, apparently representing vertebrae? Why should similar bones have been created to form the wing and the leg of a bat, used as they are for such totally different purposes, namely flying and walking? Why should one crustacean, which has an extremely complex mouth, formed of many parts, consequently always have fewer legs? Or conversely, those with many legs have simpler mouths? Why should the sepals, petals, stamens, and pistils in each flower, though fitted for such distinct purposes, be all constructed on the same pattern? How then can we explain these several facts in embryology, namely, the very general, though not universal, difference in structure between the embryo and the adult? The various parts in the same individual embryo, which ultimately become very unlike and serve for diverse purposes, being at an early period of growth alike. The common, but not invariable, resemblance between the embryos or larvae of the most distinct species in the same class. The embryo often retaining, while within the egg or womb, structures which are of no service to it, either at that or at a later period of life. On the other hand, larvae which have to provide for their own wants, being perfectly adapted to the surrounding conditions. And lastly, the fact of certain larvae standing higher in the scale of organization than the mature animal into which they are developed. What can be more curious than the presence of teeth in foetal whales, which when grown up have not a tooth in their heads? Or the teeth which never cut through the gums in the upper jaws of unborn calves? Nor is it consistent with itself. Thus the boa constrictor has rudiments of hind limbs and of a pelvis, and if it be said that these bones have been retained to complete the scheme of nature, why, as Professor Weisman asks, have they not been retained by other snakes, which do not possess even a vestige of these same bones? What would be thought of an astronomer who maintained that the satellites revolve in elliptic courses round their planets for the sake of symmetry, because the planets thus revolve round the sun? An eminent physiologist accounts for the presence of rudimentary organs by supposing that they serve to excrete matter in excess or matter injurious to the system. But can we suppose that the minute papilla, which often represents the pistil in male flowers, and which is formed of mere cellular tissue, can thus act? Can we suppose that rudimentary teeth, which are subsequently absorbed, are beneficial to the rapidly growing embryonic calf, by removing matter so precious as phosphate of lime? After an organ has ceased being used, and has become in consequence much reduced, how can it be still further reduced in size, until the merest vestige is left? And how can it be finally quite obliterated? As according to the theory of natural selection, an interminable number of intermediate forms must have existed, linking together all the species in each group by gradations as fine as our existing varieties, it may be asked, why do we not see these linking forms all around us? Why are not all organic beings blended together in an inextricable chaos? On this doctrine of the extermination of an infinitude of connecting links between the living and extinct inhabitants of the world, and at each successive period between the extinct and still older species, why is not every geological formation charged with such links? Why does not every collection of fossil remains afford plain evidence of the gradation and mutation of the forms of life? Why again do whole groups of allied species appear, though this appearance is often false, to have come in suddenly on the successive geological stages? Although we now know that organic beings appeared on this globe at a period incalculably remote, long before the lowest bed of the Cambrian system was deposited, why do we not find beneath this system great piles of strata stored with the remains of the progenitors of the Cambrian fossils? Numerous existing doubtful forms could be named which are probably varieties. But who will pretend that in future ages, so many fossil links will be discovered, that naturalists will be able to decide whether or not these doubtful forms ought to be called varieties? If then, animals and plants do vary, let it be ever so slightly, or slowly, why should not variations, or individual differences, which are in any way beneficial, be preserved and accumulated through natural selection, or the survival of the fittest? If man can by patience select variations useful to him, why under changing and complex conditions of life should not variations useful to nature's living products often arise and be preserved or selected? What limit can be put to this power, acting during long ages, and rigidly scrutinizing the whole constitution, structure, and habits of each creature, favoring the good and rejecting the bad? On the ordinary view of each species, having been independently created, why should specific characters, or those by which the species of the same genus differ from each other, be more variable than the generic characters, in which they all agree? Why, for instance, should the color of a flower be more likely to vary in any one species of a genus, if the other species possess differently colored flowers, than if all possessed the same colored flowers? Who can explain what is the essence of the attraction of gravity? Why, it may be asked, until recently did nearly all the most eminent living naturalists and geologists disbelieve in the mutability of species? But do they really believe that at innumerable periods in the Earth's history, certain elemental atoms have been commanded suddenly to flash into living tissues? Do they believe that at each supposed act of creation one individual or many were produced? Were all the infinitely numerous kinds of animals and plants created as eggs or seed, or as full-grown? And in the case of mammals, were they created bearing the false marks of nourishment from the mother's womb?